Hi and Assalamualaikum to all of my students. My name is FATIN NABILAH binti ROSELAN and you guys may call me Miss FATIN or Teacher FATIN. How are you guys doing today? I hope you guys are in a good condition and ready to learn with me asynchronously. Maybe we are far away from each other and have to learn and communicate online, but let's try our best to make this lesson work and be enjoyable. So, what are we going to learn today? In the previous chapter, we have covered chapter 12, which deals with handling the data. Do you guys still remember it? So we are going to continue our lesson today with chapter 13, which is Pythagoras theorem. Are you guys familiar with it? Well, if you do, this is going to be an easy journey for you guys, but still, even though that you have learned or familiar with this topic, I hope you guys will focus and be as excited as I am. But for students who are not familiar with this topic or with Pythagoras theorem, please do not be worried as I will try my best to help you learn and understand the whole concept of Pythagoras theorem, and I will be with you to assist and guide you every step of the way. But before I start my class, there are some rules and regulations that I want you to follow in my class. But do not be scared, student, because the aim of these rules and regulations are not meant to scare or push you away. But I want to keep the environment of this class to be positive, cheerful, and each of the students are enjoying and able to pay attention closely to my lesson without any mere interruption. As for the do's in this class, I want you to actively participate and interact with me. Well, I do not mind whether it is through a chat box or comment section that you want to speak or ask me the question directly, but please be respectful. Secondly, if there is anything that you do not understand about the lesson that I teach, please inform me and let me know right away which part that you do not understand, and I will gladly explain to you again. There is only one dose in this class, which is do not abuse the chat box or comment section with something that is not related to this class. That's all for the rules. Now let's look at our learning objectives. This is our learning objective in learning Pythagoras theorem. At the end of this lesson, firstly, students should be able to identify and define the hypotenuse of a right angled triangle. Next, students also should be able to determine the relationship between sides of the right angled triangle and then explain the Pythagoras theorem by referring to the relationships. Lastly, the students must be able to determine the unknown side of a right angled triangles. Hence, I hope at the end of this lesson, all of the students who join and participate in this class are able to achieve all of these objectives successfully. Moreover, in today's class, I will gladly explain to you in more detail about Pythagoras theorem by using GeoGebra. If you notice, we have used it multiple times in previous classes, and you guys have shown very positive feedback and responses. Therefore, in this topic, I will use the same teaching aids, which is GeoGebra, to give you a clearer picture related to Pythagoras theorem. Without further ado, let's begin our journey. Before, we have learned basic polygons in chapter 9, which is plane, figure enclosed by line segment called sides. We can distinguish all polygons by looking at the number of sides present in a plane figure. For example, we have quadrilateral, which has 4 sides and 4 vertices. Then there is a pentagon, which consists of 5 sides and 5 vertices, and a hexagon containing 6 sides and 6 vertices. And it goes on and on as shown on the screen. However, today we are going to focus only on one of the polygon called triangle, which has 3 sides and 3 vertices. So this is the triangle. 3 sides and 3 vertices. Did you know that there are different types of triangles? A triangle type depends on the length of its sides and the size of its angle. There are 3 types of triangle based on the length of the sides, which are equilateral triangle, isosceles triangle, and scalene triangle. This means that the triangle here is focused on the length of the sides of the triangle instead of looking at the angles of the triangle. Well, the triangle's name according to its angle, we have acute triangle, which means the angle in the triangle is less than 90 degree. Then we have a right angle triangle, which means that the triangle has one angle that is 90 degree. And we have obtuse triangle, which means that an angle in the triangle is more than 90 degree. Now for my students, let's see some real-world examples of triangles. In this slide, we have a slice of pizza which is in shape of a triangle. Do you like to eat pizza? If you notice, when you take a slice or a piece of pizza and it is in a triangle shape, then we have a sailing boat which the upper part is also in the shape of triangle, which is here. Can you see over here? It is in the shape of triangle. Then we also have a triangle sandwich. I'm sure that at least every one of you have already experienced eating a triangle sandwich. It is in the square, but if you cut in the half, then will form a triangle. Is there any example that you can think of? You may type it in the comment section or chat box and share it with your friends. After seeing all types and example of triangle, I really hope that you guys are now familiar and prepared to learn our lesson today. Do not worry students, we will not cover all types of triangles that I have just explained just now. Today we are going to define and learn about right angle triangle only, since it is the only triangle that are related to Pythagoras theorem. Therefore, today we are going to get to know the Pythagoras theorem. Let's get started for real now. Actually, Pythagoras theorem is very important for every single person to understand its concept. This is because it is one of those cornerstone theorems of really all mathematics. Moreover, it is very functional in geometry and also the backbone of trigonometry. Soon, when you go to the upper level of secondary high school, you will always encounter with a triangle, and you always have to apply Pythagoras theorem and trigonometry in solving the problems. You guys may also use Pythagoras in calculating distances between points. Alright, so do not worry student, it does seem a lot at first, but it is surprisingly not as complicated and very simple. That's enough on my talk. Now let me explain to you what Pythagorean theorem is. So if we have a triangle which is a polygon with three sides, can you see on the screen here we have a triangle because it has three sides. One side, two sides, and three sides. And the triangle has to be a right angle triangle, which means that one of the three angles in the triangle have to be a 90-degree angle. This angle right here is a 90-degree angle, or we could call it a right angle as well. And a triangle that has a right angle in it is called a right triangle. Therefore, the triangle over here on your screen right now is called a right angle triangle. Now, with the Pythagoras theorem, if we know the length of two sides of a right angle triangle, we can always figure out the third side by using the formula. But before going any further, let me tell you another piece of terminology related to Pythagoras theorem and a right angle triangle. The longest side of a right triangle is the side opposite the 90-degree angle or opposite the right angle triangle. So in this case, it is this side right here. This side is the longest and will have a greater value of distance compared to the other two sides. This longest side is called the hypotenuse. Make sure that you guys remember the terms of the longest sides because we both will keep on referring to the longest side as the hypotenuse instead of calling it the longest side. Again, the hypotenuse is located at the opposite of right angle triangle. I hope that we are clear so far. Triangle over here again. First of all, we should identify the hypotenuse first, which is the longest side of all among the three sides. So can you students take a guess which one is the hypotenuse? Is it this side? Or is it this side? Or is it this side? Well, firstly we should identify the 90 degrees angle first. So which is here. And the hypotenuse is located opposite the 90-degree angle, which means the side over here. So this is the hypotenuse. Then we assume for the hypotenuse to have the length of C, or C is equal to the length of the hypotenuse. Next, we call one of the shortest sides, which is the side A, and the other shortest side has the length of B. So the Pythagoras theorem tells us that A squared, which is the length of one of the shortest side, squared plus the length of the other shortest side squared, which is in this case is B squared, is going to be equal to the length of the hypotenuse squared. Or the formula looks like this. A squared plus B squared equal to C squared. Or you may rearrange the formula appropriately according to the situation, and you can write it as C squared is equal to A squared plus B squared. The Pythagoras theorem formula states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Can you see the formula over here? A squared, which is this side, A squared, plus B squared, which is B squared, which represents the side here, is equal to the hypotenuse squared, which is C squared. Note that you guys may use the Pythagoras theorem to find the length of one side of the right angle triangle if and only if you have the information of the value of the length of the other two sides. Another way to understand the Pythagoras theorem formula stated here is by using the figure in the next slides that I will explain to you. So this is the figure. If you see this figure carefully, it shows a right angle triangle paired with square polygon on each side. Let's see this A side first. If we count the mini square here, it has 4 squares. 1, 2, 3, and 4. As for B, it has 3 squares. 1, 2, 3, and for C, it has 5 mini squares. 1, 2, 3, 4, 5. And can you see this is a right angle triangle, as this triangle has one angle that is 90 degrees? Can you see over here? But what is the relationship between all of this information? Remember, I have mentioned before that the side opposite the 90-degree angle, which is C side, is the hypotenuse and the largest side of all in the triangle. In this case, the hypotenuse is C. This means that C has the longest side compared to A than B. This terminology can be accepted as we can prove it with the number of mini triangles that we have counted earlier, where C has the highest amount of mini triangle, which is 5, while A only has 4 and B only has 3. This means that the area of the square formed by the longest side of the right angle triangle is equal to the sum of the area of the squares formed by the other two sides of the right angle triangle. This defines that the area of the square of both of the shorter side is equal to the area of the square formed in the longer side. This statement is similar to the formula stated by Pythagoras theorem, which is A squared plus B squared is equal to C squared. As I cannot prove to you mathematically about the relationship of the square and the triangle as stated in the Pythagoras theorem, I am going to use digital tools, which is GeoGebra, to show the connection and association between the right angle triangle and the square. Now let's switch to GeoGebra. Hi and Assalamualaikum students. In this session here, we are going to use GeoGebra to do a little sort of visual proof of the Pythagoras theorem. Just now we have learned the definition, concept, and maybe you guys already have an idea of the theorem of Pythagoras theoretically. But through this teaching aid, which is GeoGebra, you will see more clearly the relationship between sides of the right angle triangle and why the formula of Pythagoras theorem is A squared plus B squared equal to C squared. So where does all of this squared come from when Pythagoras theorem is all about the right angle triangle? Well, let me show you all of those through this session. I have already opened GeoGebra on the screen, and the first thing that I want to do is to get rid of the X and Y axis so that it gives more spaces and we don't need to use the axis this time. So in order to get rid of the axis, you just right click your mouse and hide the axis. So it is nice, right? It gives you a lot of space. Then we create a segment. It doesn't matter how long the segment is. It is very flexible. Either you want to make it long or make it short. When you select a segment feature, which is over here, see the segment, you have to click on 2 points and the GeoGebra will produce a segment for you. So just like I said, it doesn't matter whether it is long or shorter. So let's make it up here until here. So right now we have a segment of F from point A to point B. Then we create a semicircle. So how do you create a semicircle? You go to the one of the features and choose the semicircle features. So which is here. So in order to create the semicircle, we click on the point on A and drag it until point B. So see, this is our semicircle. But remember that in the theorem of Pythagoras, it is not about a semicircle, but it is related to a right angle triangle. So we have to create a triangle that has 90 degrees in it. But in order to create the 90-degree triangle, we have to use a semicircle to ensure that the triangle that we are going to form has a 90-degree in it. So we create a point on the semicircle. You may click on any point as long as the point is on the semicircle arc. So here, see, the point C is on the semicircle arc. Now you have 3 points on the screen and you have to create a polygon by connecting all 3 points. So here, in order to create a polygon, choose these features and connect all 3 polygons. Then here, then go back to this. Make sure to go back to the beginning of the point that you started because we have to create a closed polygon. Now we have a triangle ABC. So let's hide lines that we do not want to use. So the semicircle arc is no longer to be used. So hide. So we have a triangle over here. Now the question is it a right angle triangle? Well, you can check it by using the angle features because the GeoGebra offers that features. So you may click this features, which is angle, and click the polygon. Okay, you can see over here we have 90-degree angle, 49.93 angle, and 40.07 angle. Well, these two are not really play a big part in creating a right angle triangle. The most important part, as long as the triangle has a 90-degree in it, it is considered as a right angle triangle. You may move any point of the triangle, either A, B, or C, and it will always create a 90-degree angle. Let's check it. See, it always 90-degree. The only changes is the angle over here and the angle over here. So back to our formula of the theorem of Pythagoras, which is a squared plus b squared equal to c squared. And we want to find out where does the squared coming from and what is the relationship between this square and the right angle triangle. So I'm going to explain to you right now. So every side of this triangle, which is side A, side B, and side C1, we will draw a square next to each side. But in order to draw a square that is accurately a square, there is a step of it, and I'm going to show you step by step. So first of all, let's draw a perpendicular line. So as we begin with a side A, make sure to draw a perpendicular line at the end of each of side A. So we have these two perpendicular line and we connect and we make a circle. So let the circle touch until this point to make sure this is the center of the circle. So then we find the intersection between the perpendicular line over here and the circle. So that is the perpendicular line. And in order to create a square, we create a perpendicular line between this line. So, and put it on the intersection point. So we find the intersection point as well for this line. And if you can see, we already create a square over here. So now let's create a polygon and show that it is a square. So here, we connect all the points. Okay, see, we have a square, but let's remove all the lines that we are not using. So let me remove for a second. Hide all the lines that we are not going to use. Hide, hide, and this line as well, we hide it. Then in order to differentiate between these two polygons, let's change the color of this square. So choose setting and then color. Let's use purple and dark. So, and the label as well, we might want to hide it. Hide the label, hide the label. Hide the label. Then we are going to use the same technique and ways in creating the square beside the B sides and C1 sides. So let's do it. Perpendicular line. So we create a perpendicular line at the end of both B side. Then we create a circle. Create a circle until it touch the other end. Then we find the intersection between one of the perpendicular line and the circle. Then we perpendicular line of this line as well and put it on the intersection point. Then when we find the intersection between these two lines, and then we create a polygon. So up here, the second square is formed. And again, let's remove the lines that we are not going to use. Check, check, remove, and remove the label as well. Label, label, label. So to differentiate all this square and this square, we also change its color. Setting, then we go to the color, and this time let's use blue. And we should do the last square beside the C1 sides. Again, let's do the perpendicular line at the end of both C1 sides. Then create a circle. Then find the intersection point between the circle and the perpendicular line. Then create a perpendicular line between this perpendicular line and put it on the intersection point. Then find the intersection between the first perpendicular point and the second perpendicular point. Now we have the third square and we create it as polygon. Connect all the 4 points. Okay, can you see the third square over here? Okay, let's remove the lines that we are not going to use. Hide. This line also we remove. This line also we hide. This line also we hide. And hide all the labels. So we have all of this, and you might want to close all the labels over at the end of the square. It seems more neat and nicer. Hide the label. So hide the label as well. Before we going further, let's change the color for this object. So setting, we have purple, blue. This one, let's make it orange. And let's darken a little bit. Okay, so we have a square in colors of purple, blue, and squares in orange. Remember earlier during our learning session using slides that I have mentioned that the side opposite the 90-degree is called hypotenuse, which means it is the C1 sides over here, and it will have a greater value of distance compared to the other two sides. It also means that its value is the sum of the other two sides, which according to this formula on the screen, the hypotenuse can be represented by C. Then in order to differentiate all these three squares, let's label all these squares with the same name as their sides. So in order to name it in this and to make it easier for you to see, I will create a midpoint for each squares. Midpoint over here, midpoint over here, and midpoint over here. Now move its label, hide its label. Then, in order to differentiate all these squares, all these three squares, let's label all these squares with the same name as their size. So as for the squares here, let's name it as A squared. Here, since it is side B, name it as B squared. Here, side C, C squared. So we have all its names. Now let's look at the value of each of the triangle sides and the value of the square, which will indirectly tell us the relationship between the square and the right angle triangle. With the value as well, it will also show why the formula of the right angle triangle is a squared plus b squared equal to c squared. So let's find its value. So let's find the value of a first. So we have a, which is here. A is here. Then we have value of b, and we find the value of c. You can see the preview first. So this is our value. So let's enlarge the words a little bit so you can see it clearer. Text, large, okay. Now let's find the square of all this value. So text, same way, but you press this A and power of 2. So you will have this A. Then let's find B squared. 2 equal to B power of 2. Preview. Read. Then we have B squared. And the lastly is C squared. C power of 2 equal to, find the value of C, which is C1 power of 2. You can see the preview. So this is the power. See this formula of Pythagoras theorem. Now let's arrange a squared plus b squared equal to c squared. So a squared plus b squared, which is the second side, equal to squared. So we have that. Let's enlarge all this value. Setting, text, large, okay, pull a bit, okay, so actually the a squared, b squared, c squared is the area of all these squares. If you do not believe it, let's see the area. See, the a squared is equal to 35.46, which a here is 5.95. If we input the a into the Pythagoras theorem, it is the same as a squared, which is the area of this square. Same goes for these squares and also this square. So no matter how you change the square or the right angle triangle, whether it is a minor changes or major changes, the sum of two sides will always be the value of the longest sides, which in this case is the hypotenuse. Therefore, say you might change and the value will always be the same. Can you see? When it changes here, the value over here is also changed. Therefore, the theory of Pythagoras theorem, which is the square of the length of the hypotenuse of a right angle triangle, is equal to the sum of the squares of the lengths of the other two sides, is true and can be accepted. Now, I hope that you guys are clear and understand the concept of Pythagoras theorem very clearly, because after this, we will do a few exercises together. That is all our lesson with GeoGebra. Thank you. Now I am going to show you a few examples of Pythagoras theorem and let's solve it together. So the first example, solve this triangle by finding the value of C. First step to solve is to identify what side is C. So C is the hypotenuse because it is located opposite of the right angle triangle. Can you see the right angle triangle here? And the C is located opposite the right angle triangle. Hence C is the hypotenuse. Then we label the remaining side as A and B. Now we write the formula of Pythagoras theorem because we know that we can find the value of C by using Pythagoras theorem because it is a right angle triangle. So the Pythagoras theorem formula is A squared plus B squared equal to C squared. Then we insert all the values that we have over here into the formula accordingly. Then we simplify the equation and solve for C. So I'm going to give you around a few seconds to find the value of C. So what is C? Yep, C is equal to 13. Is it clear now? Now let's see another example. So this is the next example. Solve this triangle by finding the value of B. Let's look at the triangle first. We have the value of hypotenuse and one of the sides. Why we know that this is the hypotenuse? Because it is the opposites of a 90-degree angle. So let's label it as A and C. This means that we have to find the value of the other side, which are B sides. Similar before, we can use the theorem Pythagoras to find the value of B because it is a right angle triangle. Now, we should always start by writing the formula as it can help you to see better and minimize the mistake. So we write it as A squared plus B squared equal to C squared. After that, we input all the values accordingly to their locations. After then, we leave the variable B on the left hand side and solve for B. So we let all the values on the right hand side and B on the left hand side. Then we will get B is equal to 12. Do you guys get the same answer as me? I think you are. That is all for the examples and I personally hope that it is crystal clear. Now, please open the link that I have provided to you through WhatsApp, or you may click the link in the description of this video and answer all 3 questions in the form that are related to Pythagoras theorem within 50 minutes. Do not worry, the marks of the questions are not included in any assessment. Just answer it honestly and it will test your understanding and mastery in these topics. I think that's all for our class session today on Pythagoras theorem. Remember to memorize this formula, which is A squared plus B squared equal to C squared, and understand its concept properly so that you can apply the formula in an appropriate situation. Rather than rudely memorizing the formula, it is better for you students to comprehend and understand the concept of the Pythagoras theorem, as this formula will be frequently used in the future. In fact, it is very simple. If you do a lot of practice, you will be familiar with it and it will be easier for you to memorize. You guys may think that maybe you will not use it in real life later. Maybe that you think that Pythagoras theorem will be used for your examination. But do not be surprised. There are many applications in real life that involve Pythagoras theorem. For example, firstly, we will use the theorem Pythagoras to calculate the length of staircase required to reach a window. We also use the Pythagoras theorem to find the original height of a tree broken due to heavy rain. We use Pythagoras theorem to find the steepness of the hills or mountains and also to determine heights and measurement in the construction sites. Well, that's the applications of Pythagoras in real life. For students who have problem or has any questions that you would like to ask, you can message me personally through WhatsApp, Telegram, or email me your questions, and inshallah, I will answer it as soon as possible. That's all students for our lesson today. Thank you for your cooperation.